Second. Yeah, I think it's on now. Okay, so good afternoon. For today's lab session, we're going to have two parts. I will host the first part and give you guys a brief introduction of our final project for this course. And Strongyear will give you a review session for what we've learned so far for the midterm. So, all right, let's start our first part. Let's look at the project overview. Professor Su has already given us an introduction on this full project topics. Let's go over it again. For our 599 final project, we want to have a printable wearable robot.
Look,
Yep. Hello? Is there any question? All right. So for this project, each of you will deliver an elbow exoskeleton independently, which you need to design and assemble elbow exoskeleton, use 3D printed hardware, servo motor, torque sensor, etc. You need to learn exoskeleton position, torque, also known as force, and admittance control, and realize the virtual wall feature in this exoskeleton. You need to use inertia measurement units, which also known as IMUs, which are we going to give a lecture about that later. I uses IMU as motion intention control for the elbow exoskeleton. And now let's look at these figures. On the left, it shows a possible solution. You don't have to make your design exactly like this. The layout could be totally different. You just use your imagination, use your creativity to design something of your own. And in the middle, it's an example of the mechanical parts. And the right figure shows the part that we're going to provide. So the provided part including a servo motor, microcontroller, a breadboard with cables, and the microcontroller and the breadboards with cables are included inside the Arduino kit you should already pretty familiar with by now. And we will also provide a force sensor with amplifier HX711 IMUs. You need to design the frame of the exoskeleton and give us the design of yours. And we will print out, but not all of your design. And for yourselves, you need to prepare a hex key set, pliers, and maybe screwdrivers. It depends. And here's some introduction about the servo motor. We will give you this servo motor, which including the servo rotors, the Arduino Uno that you've already pretty familiar with, that we've been learning and using for a while. The force sensor, we will provide a 10 kilogram load cell, which is 22 centimeter, 8.5 inches. Wireless, it's pre-attached. Dimensions 12.7 millimeter high, 12.7 millimeter wide, 80 millimeter long, which is 0.5 inch times 0.5 inch times 3.15 inches, and 4 mounting holes, 15 millimeter spacing on each side. One both holes tapped with M4 thread, the other side both holes tapped with M5 thread. And the sensor amplifier resistor, the HX711, we'll learn about this in the future lessons, so no need to worry too much about this. The goals for our final project is to design the elbow exoskeleton that are workable with the provided parts. And we will realize the position control. We'll realize the torque control. And for those two parts, we will just give you the code. So pretty much you just, as long as you hook up the Arduino board with the servo motor and the force sensor, you can realize this part, but you need to kind of tune it a little bit to make it more specific for your design. And the admittance control and the virtual wall control. Admittance control would be a combination of the position control and torque control. You need to read the torque, read the force from the force sensor, and use that input to control the motor. And the virtual wall control, since this is for the human body, our elbows, there's a range of motion that's from 0 degree to 150 degrees, I believe. So what you need to do is to prevent the hyperextension to prevent any injury on the body. The human in the loop control, we will use IMUs, and we will use feedback servo motor plus load cell and to control this exoskeleton. So for the tasks, design the elbow exoskeleton and send us your design for validation. The top 5 designs will be 3D printed, and the rest will receive our standard Omni Exo kit. Please notice that there won't be any deductions for just using our Omni Exo kit, but you'll get bonus if your design has been selected by us. They assemble and functional test of the exoskeleton, and they realize the admittance control and the virtual wall control, and include the code and the video links in your report. Just like the regular lab report, you copy and paste your code, and you videotape you will videotape your outcome and upload that to the YouTube, and including the link in your report. And for the optional human in the loop control, which including IMU, you will also need to include the code and the video links in your report. We will give you a link where you can,
Okay.
yes?
What's the load cell used for? Like in an exoskeleton, like what would typically be a load cell like input?
So this would be a load cell, the force sensor.
No, I know what that is, but I'm saying,
Yeah.
what would it like? How would you be able to use it in a exoskeleton? Like, what are you really collecting? What kind of data are you collecting?
Oh, about that, very good question. Actually, I'm going to give you this demo. Actually, Professor has already showed you this video. So this shows us the admittance control, which we use the input from the load cell. So the load cell, it get a signal that from one side that it need to get flexion. So the motor will just turn in, and the extension, the motor turns out.
Now that's taken from the forearm.
Yeah, so the lower part, this part that should be the forearm, this part that's be the upper arm.
But now the forearm doesn't. I mean, the wrist moves. Like you could essentially move your wrist to create a force on the load cell. How do you make how do you move your forearm to create a force?
Oh, because actually this one should be where on your arm, and this middle part, the servo motor should be aligned with your elbow joint. It's not how you are wearing right now. I'm just showing you guys how it should look like, because if I just put it on my arm, it wouldn't be so clear. So I was just giving you guys a demo. So this part, the servo motor should be aligned with your elbow joint, and this part should be your forearm. This one should be your upper arm.
I got it. I understand.
Yeah.
What's
So
going on
what
here.
you like? It's like if you want to show us your biceps, you just flexion. You just flexion your forearm, and then the forearm will apply a force to this part,
Right. I thought this was for disability, for a certain disability. Like usually you get like people that can't move their arms at all
Oh yeah.
would use this.
Yeah, that'll be a very great idea. But right now, I think that would be very difficult to realize for this level. So we would just like you guys to have a very preliminary design of how we can realize these functions. Great question. So do you guys have any other questions?
When
Is
is
this,
this due? That was my other question.
I'm sorry?
When is this due?
Oh, this is the final project. So this
Right.
will be your final. Uh, let me
Which
check.
when?
So yeah, let me check the syllabus. So it should be in December. So you still have time.
So I'm assuming December like 20th around there. Like
Yeah,
okay.
let me look at the syllabus. Just give me a sec. Well, the internet connection is pretty slow. Yeah, it should be around December 20th. So you still have a lot of time. No need to worry about that. And we will give you more lessons and more lives about this project, about the motors, about this force sensor, and about IMUs. So you will get sufficient knowledge about how to do this project. Do you guys have any other questions? If not, I will let Shuangyue give you this lecture about uh, midterm. All right, thank you very much. Okay.
Thank you, Paul. Hello, everyone. Can you hear me?
Yes.
Thank you. Hello, I'm Shuangyue Yu. I'm Professor Hao Zu's PhD student, and today I'll give a brief review about our midterm. Give me a second. We plan to have a midterm on October 21st this semester. Give me a second. Okay. It will start from 2 p.m. to 3:30 p.m. on August 21st. And I will upload the field test around 1:30 p.m. to ensure everyone can find the fields. And the midterm is a closed book and online midterm. You need to log in Zoom and answer questions. The scope of the midterm is include the lecture from week 1 to 7, but mainly focus on mainly focus on the motor control encoder, signal communication, modeling DC motor, motor control encoder, and the PID control. And I will upload the midterm exam to the following link. And so please send the email, the answer sheet to Professor Hao Su and our lab's PhD student Sainan Zhang in the following two email before 3:30. And the format is the email title is midterm, first name, last name, and the answer sheet name, midterm, first name, last name, .pdf. Here I would briefly talk about some midterm example hints. The midterm will include several optional questions and some questions you need to answer. It will include the actuator structure, so you need to know the each part function, and include some microcontroller programming. You need to check the Arduino Uno, the programmable I/O, and our labs, lab 1, lab 2. And second, a third is about the serial communication and parallel communication. You need to know the principle of the bound rate and do some basic calculation. The fourth is about DC motor. You need to know how the principle of the DC motor and the driver circuit, the PWM principle. And the fifth is about encoder. You need to know the principle and resolution and the difference of different type of encoders. The last is the PID control. You need to know the principle and the explanation and some coding. For the microcontroller specification, you need to have some basic programming skills, and such as the analog input, analog read, analog write, digital I/O, analog I/O, PWM function. You can find some more details on the forum of the Arduino Uno. And for the serial, for the communication, you need to know the difference between the serial and the parallel communication. And you need to know what the bound rate means, and some basic calculation about the choose the right bound rate, or choose the doable bound rate for your for the certain requirement. Note that 1 byte equals 8 bits. And for the mechatronics part, you need to know electronic actuator. It consists of the motor, gear reducer, encoder, driver, and controller. You need to know all the function of the different part. And you need to know the bridge for the DC motor driver. And you need to know how to use the PWM control, PWM signal to control the actuator. Particularly the PWM is a control signal. It's not the actual output voltage of the motor. For example, if you have a motor that have the nominal voltage for about 100 volts, but your PWM signal can only have 3 volts, 3 or 5 volts. And you need to know how each bridge work, so which gate you should turn on and which gate should not turn on at the same time, to cause the shortcut. You need to know the working principle of the pulse-wise modulation, the PWM function. In general, the PWM function, we can use it to control motor to generate a average equivalent voltage, but it also can be used to work with the ADC, the analog to digital converter, or the digital to analog converter. But you will focus on you need to know the PWM can be used for average equivalent voltage. We have some questions about this. And for the encoder part, we introduced the different type of encoder, like the incremental encoder and absolute encoder. You need to know, for the absolute encoder, you need to know how to calculate the resolution and the gray code. And for the incremental encoder, you need to know how the working principle and what the difference between the two-phase encoder and the one-phase encoder. And based on the sensing technology, we introduced the magnetic encoder and optical encoder. the magnetic for multi-channel optical encoder, we have multiple pair of LED light, and for magnetic encoder, we have multiple magnetic poles of magnetics. So you need to know how the incremental encoder works for both the optical type or the magnetical type. And here is a two phases incremental optical encoder. You need to know the resolution. You need to know how to calculate the resolution of the encoder, and what the difference between use a two-phase encoder compared with use a only one-phase encoder. And for the control part, you need to know the control part is technically a feedback system, and the composition. You need a controller, the driver, actuator, and sensor as a feedback. And for the PID control, you need to know how to implement the PID control algorithm into program C, like today's lecture slides. Yeah, I think that's all. And if you can answer all the above questions, I think you will get a very good scores or very good grade. So is there any questions? I cannot let you know which we will ask, but I think I just introduced almost most of the questions.
Sorry, did you say that this was closed book or open book?
Closed book.
Okay, thank you.
Let me think. I need to discuss with professor for a formal answer because I'm not very familiar with the last semester's what we do, but I'm pretty sure based on the last semester's midterm feedback, student got good scores. So because the midterm is at October 21st. So next week on the lecture, we will finalize the midterm plan. But the midterm question is what I reviewed today.
Okay, thank you.
Mm-hmm. Welcome. Okay, so is there any more questions? We will share this slide to our student folder, and we are currently optimizing our week 4 and week 5 slides, and I will upload it to the shared folder. Yes, please.
So where are the recordings for the lectures in the lab? I couldn't find them in the Dropbox.
Excuse me, can you repeat this?
Where are the Zoom recordings?
Sorry, which one?
Where are the Zoom recordings located?
Oh, she's asking where in Dropbox.
You mean the student shared folder?
No, she's asking for the recordings.
The recorded lecture.
Sorry, I cannot hear the whole sentence.
The recordings for the classes, where are they? They're on YouTube, right?
Yes, I will let Sainan or Bowen share the recorded video link through email and put it to the Dropbox after today's lecture, okay?
Thank you.
Okay, welcome. So we may have some minor update last weeks about the midterm exam, about this slide. This slide may not finalized, but the scope is fixed. Okay.
Why didn't you put the midterm on Blackboard and make it easier for us to submit and do the midterm itself?
Yes, that's a good plan, and I need to chat with them because I personally don't know how to do that, but I can chat with them. Okay.
All right.
Thank you for your suggestion, and I will chat with them. Okay. So any more questions? uh, about this. And
You said it was closed book, right?
yes, yes.
I'm just curious. How are you going to make sure that it's closed book?
uh, I think we need to we will require you use Zoom and maybe not fully closed book. I need to chat with professor. Maybe you can use some slides, but I'm not sure. I need to chat with them.
Oh, you're not sure? Okay.
Yeah, but I'm sure about the questions because I already prepared the questions. So let me repeat one thing again. Is you need to know some programming about Arduino Uno. The question is mainly focused on the serial communication, motors, encoders, PID control, and Arduino programming, and like this. Okay, level 1, level 1, level 1, 2, level 1, 2. Okay. So is there any more questions?
Yeah, I have a question.
Yes, please.
So you said in the very last slide where you said that we gotta know how to implement the PID controls, right?
Yes, yes.
So my yeah.
I'll go to that slide. Yeah, please continue.
So my question is that is there gonna be a class or a lab on how can we implement that concept in the C language into Arduino?
No, but we only need to implement the key algorithm of the PID control. You only need to write several rows of the code. You don't need to do some definition of each of the variables. You only need to write the PID equation into the C code. And I think it's basically already written in our slide, but have some very small changes.
All right.
Okay. Yeah. So don't worry about this part. I'm pretty sure this part already right in slides.
Okay.
Okay. So that's all, and you can ask any questions. And the midterm is on October 21, so it still has a lot of times. And I will work with our lab member and professor to prepare a good final project for you. So we are currently working on the final project, and I hope on the meanwhile you can start trying to design something, design the axle, elbow axle. Okay.
I'm sorry. One other thing. You said October 21st, right?
Yes, October 21st.
So I may have a conflict of interest because October 21st runs on a Monday schedule. So do we know what time?
I'm not sure. Sorry, it's your personal issue or the CUNY calendar issue?
Yeah, October 21st runs on a Monday schedule. So
CUNY.
around this, yeah, CUNY. October 21st is Monday schedule, I think. So
okay,
yeah,
so I'll look into detail. I'm sorry about this.
yeah, because I have a midterm at that same time for
I
my
see,
Monday
I see.
class.
Okay, so we will check this into details, and if we don't have lecture in October 21st, we'll postpone the midterm. And if for all the students, if you have some personal requirement about the midterm, such that you cannot make it on time, you can email professor and sign on. Okay, but for if it's a CUNY calendar issue, we will figure it out.
Quick question for
Thank you.
the exoskeleton design. Does it matter what type of software we use? to design the model?
That's a good question. No. We recommend you use Arduino Uno. You can use Arduino IDE, and you can use some different
I'm not talking about
environment. You can use Raspberry Pi. We don't care. But our example will made by using Arduino Uno, programmed in Arduino IDE.
No, I'm talking about the design software.
Design. Okay. Oh, sorry. I didn't follow you. So. You can use SolidWorks 2016. I think CUNY provide this, and you can use the others. And I discussed with Bowen. We recommend you work on the mechanical design first, and when you send your designed CAD fields or printable STL fields, we will review it and check if we need to. We will print for you, or we will print a standard version for you. But yes, you can use any software.
Okay, thank you.
Can you give us the link for SolidWorks? You said 2016 is provided. I don't have it.
I will check it. Okay.
Professor, so I think if you go on SolidWorks, the official website, they don't have the 2016 anymore. And the last time the professor we asked the professor what kind of version could work. He said any version could work, because for me personally, I have the 2019 version.
Oh yeah. For us, we don't. It's okay for us that you use any software, any version.
Okay.
Yeah. But I think we need to check if our school still provide SolidWorks for you. But for us, we don't care you use any software or any version. Okay. And if you still have the issue about the design, don't worry. This course is about mechatronics, which is about mechanical design, sensor, actuator, and control. So if you will not complete a very good mechanical design, that's totally okay. We will print a standard version for you. The principle of this course is we want everyone can try your best to use the final project to learn more or do more about the mechatronics. Okay.
So you're gonna find out for us if we can get SolidWorks somehow?
Yeah, I will chat these three things to Woven and the professor. Include check the course, the October 21st, check the.
I think the October 21st thing, we got to sort it out in the chat. If you look at the chat, it says that October 21st is good.
Yeah, we got to sort it out. It seems my other professor's the one that's wrong. So he has to reschedule that test. So we're good. Thank you.
Okay, thank you. Okay, so the SolidWorks I will check. Okay.
Perfect. Thanks.
Okay. So so let's stop today's course. Is that okay?
Perfect. Thanks.
Okay.
See you guys next week.
Okay, so thank you everyone, and hope you have a good day. Bye-bye. Okay, for more questions, you can send email to the professor and sign anytime. Okay, bye-bye.